everybody, it's Wednesday on the Game Audio Vlog. We're continuing with our expedition through sound design for a 2D game with Unity and Wwise. It's episode number 28 now, which means we're inching ever so close to episode number 30, which is exciting because that was a goal of mine to do this for a full month, which will actually be a month and a half by the time that this is done. Today we're going to, instead of walking through something absolutely specific, I'm going to expand a little bit on stuff that I did yesterday with the red ship engine. So if you're implementing for the green ship, and if you're completely unfamiliar with what I'm talking about, go back and watch the beginning of the videos. We're working on a sound design for a 2D game called Into the Space, freely available on the Unity Asset Store. Just continue to follow through. So if you're, again, implementing for the green ship engine, what I did was the exact same thing that I did for the red ship engine, making the adjustments for the EQ on the pink noise a little bit different and less intense. I called it like the mid-level ship engine. It should have a rumble all in the mids rather than from the highest to the mids, just all in the mids, from the top of the mids to the low mids. And then kind of matching at the very end, it should sound somewhat like the blue ship engine that just rumbles all its way down. So if you want to know how to implement all of that, I suggest you go back and watch the red ship engine and then tweak it so it sounds different, because the implementation is literally exactly the same. But instead today I want to show you and elaborate a little bit on the code that I didn't touch on yesterday, which is panning, and then we're also going to talk about an enemy count, which isn't going to come into play right this second, but will come into play when we talk about adaptive music. So if you look here, I've got the code for the green ship, which if you look in the public variables section, where all the variables are instantiated, if you don't know anything about code, it's where you see public on every line it starts. A public variable, for a layman's explanation, is a variable that is available to any part of code, essentially. You can access it anywhere. A private variable is accessible just within the specific function that it's working in. So what we're looking at specifically are public int RTP See RND, which is a random number that we will use to modify our RTPCs, and then we'll give that an actual a number between between 0 and 2. We'll give it a range. That's what I was looking for. And then public static int green count. I don't remember why I called it a static variable right now, but that was probably important, so type in static if you're following along at home. Green count, I implemented the same thing, red count and blue count in each of the individual enemy ships. You'll see why in just a minute. So I'm going to go down to the start function. It says use this for initialization above that. The start function is where the prefab, in this case the ship, starts within the game. It's where it's built, essentially. I'm not exactly the person to talk about for what all Unity code means and what the difference is between all of it in C#. I can tell you, though, that the start function is where something starts. Straightforward and simple. So you'll have here where get component rigid body 2D velocity. This is where the enemy ship is created and moved. Essentially, it gives a speed and the transform position to the actual physical ship itself. Then the next line down is one we create. So you want to type in RTP See RND, which references the random RTPC variable. That will equal a random range. So random.range is how you call that, but in English this would be a random range, and then it's between 0 and 2. So whenever the ship starts, this variable will instantiate and get a random number between, it'll be 0, 1, and 2, just completely randomly when you begin, when the blue ship is created. For each individual blue ship, we'll create a brand new RTP See RND variable that applies to the ship, and it's either 0, 1, or 2. Then we want to take green count and add +1 to it. So this is a cheap way, a very cheating way. If you're writing code in a lot of different languages, it lets you just take an integer variable and then type ++ next to it, and that's to iterate it by 1. So if it's 1, then it'll be 2, and if it's 2, it'll be 3, so on and so forth. But so if we were to make a brand new green ship in this case, it would go from the count of 0 to the count of 1. And if we had 2 green ships on the screen, then when start called for the third green ship, it would go from 2 to 3. Very straightforward, hopefully. Then the last line is again one we create. It's called AK Sound Engine .set RTPC value. This in English would be AK Sound Engine is Wwise. So Wwise, please set the RTPC value of, and then we're typing enemy ship _ x-axis. So we want this to apply to that game sync. That's if you go in the game parameters tab it's either game parameters or game syncs. I think it's the game syncs tab in the game parameters value. It would be the game parameter enemy ship _ x-axis is what I've called it. You can call it anything you want because it's definable completely by you. So, but we want to do the rest of the function to this enemy ship x-axis. So what we're pulling here, transform.position.x, gets us back the value of the x-coordinate on the ship itself. So the x-coordinate is left and right. If you've done a coordinate plane in math when you were in elementary or middle school, this will come in handy again. So transform.position.x is the x-coordinate, transform.position.y is the y-coordinate. It pulls that coordinate immediately when this line of code is called. The nice thing is, for this game, the x-coordinate never changes. When a ship is made on the screen, it always stays in one place. It doesn't move left and right. So if we get the x-coordinate at the very beginning when the ship is started, then we'll have it for the rest of time. We don't need to put it in an update function where it consistently updates. Game object just refers to the object that we're working with. So it's either the green ship, the red ship, or the blue ship, depending on what code you're in. So again, to put this all into one big thing, this is, hey Wwise, set the value of the RTPC enemy ship _ x-axis to the x-coordinate of the green ship, in this case. So AK Sound Engine .set RTPC value, and in parentheses, enemy ship _ x-axis, transform.position.y to the game object. Hopefully that's straightforward. If that's complicated and you still don't understand it, comment below. So that's how we set an RTPC value for Wwise to say, hey, this is a value that you need to use for panning. And I will show you that in just momentarily of how we actually do the panning in Wwise with that. And then I'll go through it one more time just because this is what we did in the last video, but just to clarify it. With the update function, you do the same thing. Hey Wwise, please set the RTPC value of the enemy ship y-axis, which y is your vertical axis, coordinate plane. You want it transform.position.y, so it pulls the y coordinate from every single frame, and then it adds our RTPC random number to it, plus RTPC random. You don't have to do that, but I wanted a more dynamic experience than just we start at 6 and then we go to -6, which is the top and the bottom of the screen in this game specifically. It might not be the same thing in every 2D game, so you'll have to test that and see. But I wanted it to be that the ship doesn't always start from the same tone and end in the same tone. It can end in the same tone, I feel like. That's fine, because the ship's going to shoot down the screen and it's going to be quiet and rumbly by the time it gets all the way down the screen. But I wanted some to sound like they were slightly faster and some to sound like they were slightly slower. And an RTPC, a random value for the RTPC, to add to what we've already got for the position, will add a variable of essentially 3 positions, I guess you'd call it. Excuse me. Because it'll either be 0, so it won't change, +1, or +2 to the RTPC value. Excuse me, I had to clear my throat there. So that's the code, all wrapped up in a nice little bundle. And then all of the rest of it already exists, so you don't have to worry about anything. And if for some reason you're seeing code on your screen that isn't on my screen, go ahead and delete it. At least if it refers to audio, I mean, because you might see like audio source and then it referring to like the ship firing or something like that. You can go ahead and get rid of that. So the next interesting thing we're going to talk about before we jump into Wwise and show you what to do on the other end in Wwise is this a green enemy tag and how to use the destroyed by boundary script. So there is, I don't remember exactly, I guess it's, destroy by boundary _ script or destroy by boundary .script. Destroy by boundary, that's what I'm trying to say. So this is where the ships are destroyed by a boundary outside of the screen. So the ship goes off the screen, and you don't want to hold that in memory in your computer because you can't see it, and it's not worth anything because you can't shoot it. So you don't want 100 ships at the bottom of the screen just sitting there. So when the ship reaches a certain value and a certain boundary on the XY coordinate plane, the game automatically destroys the ship. You could use this if you are a programmer to like give the player negative points, or to kill the player if you didn't want the player to let a ship go by, or you can do all sorts of interesting things with the destroyed by boundary. But in this case, what we're going to do is to subtract the count of the ships. And you can also apply this to when a ship is destroyed in the code, which actually I don't think I've talked about or have shown. But if you look within the same enemy green ship dot script, or whatever it was called, the script that we were just in, if you were to scroll down, and we actually used this earlier where when you destroyed the enemy ships, there is an explosion sound. Within there, you could put you could negative the enemy count. So it would be green count minus, red count minus, whatever, to subtract an enemy for when you blow it up. That's how you would do that. In this case, what we're going to do is I have tried to figure out a way, and I successfully did it, to refer to a variable that we created in another script, in another function. So in this case, you'll see here I made public static int green count at the very top of your screen, top left, at the very bottom of the public variables. We want to refer to this variable, so we want to refer to our regular count in a completely different script, which this is the destroyed by boundary script. How we go about doing that, in this case, the way that I figured out, I'm sure that there's many other ways to do it. If you find a better way, go ahead and comment below. Would love for you, if you're a genius coder, to tell me a different way to do this. If you go into the inspector on your prefabs in Unity, just again double click on your red ship, blue ship, or green ship prefab, you'll see this little thing up at the very top of the inspector. It's called tag. And in this game, as far as I could tell, the code wasn't using the tags for anything. Nothing specific to hold on to. So if you click that drop down, at the very bottom of the drop down it says add new tag. So I added tag green enemy, red enemy, and blue enemy under each of the enemies themselves. So green enemy only got the green enemy tag, red enemy only got the red enemy tag, blue enemy only got the blue enemy tag. So you see here it says green enemy. This is because the specific tag for the green ship is green enemy. Each prefab can only have one tag, to my understanding. So you have to be specific with it. And I didn't want a complete enemy count, though I suppose you could do that too. I think actually I ended up making a complete enemy count, to be honest. But I did want to figure out how to do it individually, so I didn't have to, keep either a full enemy count, and I just wanted to try some new stuff and learn about it. So in this case, destroy other.game object. This is the regular code for destroy the other object that's not you, I believe. Within the void on trigger exit 2D collider 2D other script. I think that literally is the only line in this thing before we added code. So I added some braces, and I said if the other object.tag equals red enemy, then within the enemy red script, take the red count variable and negative it by 1. This is the exact same thing I'm saying for blue and for green. So this, again, if other.tag equals red enemy, then enemy red underscore script red count minus. The way that this is working is we don't need braces, because the way that code works, if you are only doing one line of code within an if statement or within a function, you don't need braces. If it's one single line of code, you can cheat that way, just like we're cheating with a minus. So it keeps it a little bit cleaner. So again, if other.tag, which is like the other game object that we're talking about right above, equals is the way to refer to a equality within code. If you're trying to do a not equals, it's exclamation point equals. If you're trying to refer to a less than or equal to or greater than or equal to, it's the same thing. So you're less than or greater than and an equal sign. That's the reason why you have 2 equals here rather than just 1 equals, because you have all of these other versions that you can have less than or equal to, not or greater than or equal to. So you need, for regular computation, you need 2 symbols there. And then we're looking for a red enemy, blue enemy, or green enemy for the tag. And then what we're doing within the function is enemy red underscore script dot red count minus minus. So the variable of red count from the enemy red underscore script, we want to negative that by 1. The other way you could do this is enemy script dot red count equals enemy script dot red count minus 1. So that would just be redundancy of redundant department, right? So we don't want to do that. But that's the way to keep your ship counts in order for how many ships you've got on screen. Literally that simple. That, and of course to take that red count, blue count, or green count and negative it by 1, subtract by 1. That's the word, subtract. I know math, right? Subtract it by 1 when a ship is destroyed, just in your regular code. So going into Wwise, the game parameters for the x-axis for the panning, I'll show you now. What I did was made a new game parameter, so it's the game syncs tab within Wwise, and then you want to use a game parameter. In this case, I called it enemy ship x-axis. I'm not being specific on the color of the ship or anything, it's just all enemy ships, because it would be the exact same for every enemy. You go ahead and make that game parameter, and then the right side picture here is what you want the parameters values to be. So the default is 0, so that's center on the screen, and then your minimum is negative 3.12 and your max is 3.12. That's just the far right and the far left for each of for this specific game. The way I figured that out was using the player ship the transform dot position dot x of the player ship returned in a debug.log statement. The way that you use that is you type debug.log and then in parentheses transform.position.x within your player ship script, I believe is what it is. So, and that's within the update function, because you want that to update once per frame. And then you fly your ship all the way to the left, and you fly your ship all the way to the right, and then it will return the transform.position.x of the player ship. That's how, I got those values. So then once you go and create your enemy engine sound, in this case, you'd have to do this 3 times, because you don't have to create the game parameter 3 times. You have to create the RTP See 3 times within your each individual ship engine sounds. So here you see the positioning tab, and then 2D and enable panner is turned on. This is the parameters of my engine mid for my green ship. So my green ship engine's game parameters, or my green ship engine's audio parameters, the positioning parameter has 2D enable panner on. So moving forward, and then you click the RTP See tab, and this is what it looks like. You add an RTP See here at the bottom, you click left right pan 2D, and then you add enemy ship underscore x-axis for the parameter. And then in this case, I only panned it to 50 and negative 50, so I'm not actually even doing the full width of the panning. I think I panned the player ship further than I did the enemy ships, to be quite honest. And that's just really, more than anything, just because I wanted to test it. And then also, I didn't want the field of the panning field to get too wide on headphones. I didn't want it obnoxiously all the way to the left or all the way to the right. I wanted you to have an idea of it, but since you can see the ship on the screen, I kind of wanted it in both ears, and didn't want to make just the spectrum too wide, because it doesn't need to be full stereo or anything like that. So, and then that's it. You test all those things, they're done. By the way, you'll see here where I've got all these things, and there's the RTP See tab, and you'll be like, Adam, this isn't what you did last time, because the Y ship axis isn't, the ship Y axis isn't right here right now, and that's true, and that's because the ship Y axis RTP See is actually on the EQ parameter or the EQ effect of the ship engine. So if you click the effects tab there that you can see on the screenshot, then you will go into your EQ, and then you add the RTP See there. So that's a kind of cool and different thing that if you're not too familiar with like the complicated audio routing and like DAWs and on audio boards and stuff, and how deep you can get into it. Wwise lets you put RTP See parameters in completely different places. So in this one instance right now that I'm showing you, we have it on the sound itself. The RTP See from yesterday's video is on the effect that's on the sound. So it's actually affecting the effect rather than affecting the sound itself. A little bit of a mind twist if you're not used to that, but we wanted to affect only the effect last time, and this time we want to affect the sound itself, or the positioning of the sound itself. So that's it. Again, go ahead and test these things, and hopefully they worked out for you. And tomorrow I'll be back talking about asteroid explosions, some, and maybe a little bit of other stuff too. Not sure off the top of my head, but I'll be back. Thanks for watching this really long video where I tried to elaborate a little bit more. If you got any questions, comment below or get me on Twitter at Adam T. Croft. Have a great day.